So we're going to be taking a look at factoring by finding a greatest common factor. Alright, so the first thing we need to do is review a few vocab words. So prime numbers. What is a prime number? Well, a prime number is a number that is only divisible by itself and the number 1. So for example, the number 3 can only be written as 3 times 1, so that's a prime number. The number 5 can only be written as 5 times 1, so that's also a prime number. Now, what are factors? Well, that's just what I did right here. So, for example, for the number 3, the factors of 3 are 3 and 1. All right? Now, they're the numbers that you multiply together to get that number. So, for example, the number 12. Well, the number 12 I can make in multiple amounts of ways. I can do 4 times 3. I could do 6 times 2. I could also do 12 times 12 times 1. Okay, so that means that 4, 3, 6, 2, and 1 are all factors of the number 12. Now, when I combine the idea of a factor and prime, I want the numbers that are factors of another number that are prime numbers. Okay, so I want you to think of factor trees here. So for example, the number 12, you would break down into, let's say, 6 and 2. Now, 2 is a prime number, so I can't break that down anymore. But 6 can be broken down into 3 and 2. Now I have the prime factorization of the number 12, okay? It's 3 times 2 times 2. 3, 2, and 2 are all prime numbers, so that's the prime factorization. So here are some examples. Like the number 6, I would break down into 3 times 2. Okay, 3 times 2 gives me 6, and 3 and 2 are both prime numbers. 12x squared, well, the 12 will break down into, we did that over there, 3, my bad, it'll be 6 times 2, and then 6 will be 3 times 2, and then x will break down into x and x, okay? So the prime factorization would be 3 times 2 times 2 times x times x. 36, well, 36 is 6 times 6, and then 6 breaks down into 3 and 2, 3, 2. X cubed would be x squared times x. Well, x squared is x and x. So you can see that the prime factorization would be 3, 2, 3, 2, x, x, x. Okay, and you would do the same thing for 18x squared y cubed. All right, so hopefully you get the idea. Prime factors are the very, very basic factors of a number or polynomial. Okay, so we're breaking it all the way down to the bare minimum in our outline, our skeleton of this number, okay? All right, so what are the common factors? So now we're going to talk about common factors. So we talked about factors, but now we want to know what two numbers have in common. So for example, the number 4, well, the number 4 is 2 and 2. The number 6 is 3 and 2. Therefore, the common factor is 2. Okay, notice how both of them have a 2 in common. Now, what about 3x and 3y? Well, 3x is just 3 times x, and 3y is 3 times y. Therefore, what they have in common is 3. Okay, 12x and 4. Well, 12x, the 12 can be broken down into 4 times 3. And remember, 4 is 2 and 2. The x is just x. So when it comes to what it shares with 4, well, 4 is 2 and 2 again. So since both of them have a 4 in common, 4 would be our common factor. Or you could say the 2 times the 2, or 2 times the 2 would be our common factor. Now, they also have a common factor of the number 2. So they also share 2 as a common factor. So 12x and 4 have a common factor of 4, and they have a common factor of 2. All right, so now we're going to look for the greatest common factors, okay? So let's look at 14x squared y and 28x. So we're looking for the number that is the biggest that goes into both of them, all right? And then 28 is 7 times 4. 4 can be broken down into 2 times 2. So I want you to notice, what do they have in common? Well, they have a 7 in common, and they both actually have a 2 in common. What does that mean? Well, since they both have a 7 times a 2 in common, they actually both share a factor of 14. Because I could have broken down 28 into 14 times 2. All right? So that means my greatest common factor is going to be 14. And then they both share an x. X squared and x. What's the biggest x value that will go into both? Well, that's going to be just x. So the GCF there is going to be 14x. Looking at the bottom one, 7 times 1. And then I'm going to have 7 times 3. And that's also going to be times -1. So what is the GCF here? Well, they both share a 7, and that's it. All right? And then they both have an x. And the biggest x that each has is just 1, because you can't pull out more than this guy has. I can't say an x squared or an x cubed is a GCF of this guy, because the biggest he has is just one of them. So the greatest common factor there is just going to be 7x. All right, so now we're going to factor by finding a GCF. Now, we already looked at these terms earlier. When we looked at 14x squared y and 28x, we said 14 was 7 times 2, and 28 was 7 times 4. Okay? Now, I could break that down further, but remember, we're just looking at GCF here. So they both share an x, and they both share the greatest common factor is 7. And then they also share a 2, okay? Both of them share a 2. Now what this means is the greatest common factor is going to be 14 when I multiply those two numbers together, okay? So my GCF here is going to be 14x. Now the x because they both share an x, and 14 because both of them are divisible by 14. Now, whenever we're factoring, we pull out the GCF, we factor it out, and what we're actually doing is dividing the term by that GCF. So for example, if I had 14x squared y, and I divide it by 14x, what I'm left with is just, well, 14 divided by 14 is 1, x squared divided by x is x, and y divided by nothing on the bottom is just y. So what I'm left with is xy. All right, now we repeat this process with the 28. Now you don't have to show this division step, but I want you to understand what we're doing. 28x divided by 14x. Well, 28 divided by 14 gives me 2. And x divided by x just gives me 1. So that's it. Now remember, factoring is the inverse operation of multiplying these together. So that means if I go ahead and multiply them through, I should get what I started with. And I will. I'll get 14x squared y plus 28x. Now I want you to notice that inside the parentheses here, x, y, and 2 have nothing in common. They have no common factors. They shouldn't, because we should have taken out the biggest factor in front. Okay, so always make sure you're looking for the greatest common factor, not just a common factor. All right, so let's do the same thing with the bottom. We have 7 times 1. We have, again, 7 times 3. Now, they both have an x in common. So my GCF here is going to be 7. So I'm going to pull out a 7. I'm going to pull out an x. And what I'm left with when I divide through, well, 7x cubed divided by 7x is going to leave me with just x squared. And then negative 21x divided by 7x is going to leave me with negative 3. Now, notice, x squared and 3, nothing in common. If I were to multiply these guys back through, I get 7x cubed minus 21x, which is exactly what I started with, so I know that I did it correctly. Okay, so yes, you can still check your answers with these types of problems. All right, so now we want to factor out the GCF. So we need to look for what do these guys have in common. Now this one's a little bit different, okay? But if you look closely enough, you see they both have an x plus 5. All right, now what does that mean? Well, that means I can pull that term out of both of them. So if I pull it out of both of them and put it out front, remember that's like doing x squared times x plus 5 divided by x plus 5. Now since they both share a quantity, this divided by this give me 1, and I'm just left with x squared. So when I factor that out, I'm left with x squared. When I factor it out of the second parenthesis, I'm left with just the coefficient, so negative 7. All right, so this is factored form. All right, we took out the GCF, and that guy sits out front, and then what's left stays inside the parentheses. So these two things are equivalent. If you were to multiply it back through, you would get the same answer. Now we're going to factor by grouping. So when do we factor by grouping? Well, there's some key signs that I want to look out for to know that I need to factor by grouping. Now the biggest thing is that every term in your polynomial will not have a greatest common factor. Okay, so they don't all have something in common. Some of them do, but not all of them together. Now the other big sign is there's usually 4 terms. All right, so 4 terms with no GCF for all of them means factor by grouping. All right, so for example, I have x cubed plus 7x squared plus 2x plus 14. Now, not all of them have something in common. These guys have x's, but then 14 doesn't. 7 and 14 have something in common, but then x cubed and 2x don't have that same thing in common. 2x and 14 have something in common, and then x cubed and x squared have something in common. So what you do with grouping is you group things together that pair up, that have something in common. So if we look at x cubed and 7x squared, well, they have a GCF. Their GCF is going to be x squared. All right, so that means that I can factor out an x squared, okay, and I'd be left with x plus 7. And then looking at the second set, I have 2x plus 14. Well, what do they have in common? Well, they both have a factor of 2. So I can factor out the 2, and I'm just left with 2 times x plus 7. So once we have paired up and then factored out the GCFs out of the terms, there's something you should be noticing now, all right? This guy and this guy look exactly the same. Now remember, when 2 terms have something in common, I can factor out that term and put it in front. So that's exactly what I'm going to do. I'm going to factor out the common binomial. So I'm going to pull the x plus 7 out, and then what's left, let me use a different color, what's left stays in another parenthesis, and I carry the sign of this guy. So I'm going to have x squared plus 2. All right, now if I were to sit here and multiply this back through, I would get what I started with. All right, so we just factored by grouping. All right, so we are going to multiply it back through just so you believe me that that works. Okay, so x times x squared is x cubed. X times 2x is plus 2x plus 7x squared plus 14. Rearranging from highest degree to smallest degree, you can see that I end up with what I started with before I factored, which is exactly what I want. So you can always check your answer. Taking a look at all 4 terms, I can see that they don't all share a GCF, so I know I'm going to have to factor by grouping. So I'm going to group these 2 together and these 2 together. The GCF of y cubed and 2y squared is going to be y squared, so I'm going to factor that out of both of them, and I'm left with y plus 2. And then I'm going to take out the GCF of 6 and 3y, which is 3, and I'm left with 2 plus y. Now I know that y plus 2 and 2 plus y is the same thing, because with addition it's commutative. I can write it either way. So I'm going to go ahead and rewrite that. You could skip this step. Now I can see that the GCF is going to be y plus 2. Both of those have it in common, so I can pull it out to the front. I can factor it out and put it out front. And then I'm left with the coefficients here. So I'm left with y squared and plus 3. So those are going to go in my back binomial. And then of course I could sit here and multiply it out to check that it matches what I started with. Alright, now give these a try.